Hello and welcome to Chemistry Nuggets, where you can polish your knowledge and clear your doubts. So friends, today's video is about how to draw the structure of BF3, boron trifluoride. So let's start the video. But before starting, if you haven't subscribed the channel, please subscribe, and if you like the channel, press the like button. Thank you. So friends, when we are starting to write BF3 structure, first of all, we need to understand the valence electrons. So boron is having atomic number of 5. So its valence electrons are 1s2, 2s2 and 2p1. This will be the outermost shell electrons are called valence electrons, and in boron case it is 3 valence electrons. In the same way, for fluorine, the atomic number is 9, 1s2, 2s2, 2p5. That is, the valence electrons are 5 plus 2. It means 7 valence electron. So now when we are going to draw a Lewis structure, only valence electrons should be shown in that dot structure. One thing. Second thing, we need to know that whenever we are writing a dot structure, Lewis dot structure, we must complete the octet of each and every atom. These two things we need to keep in mind, then we'll start. Now, one more thing, that there are two atoms, one is boron and one is fluorine, which should be in center and which is surrounding. We will have one more trick. The atom which is least in number will be a central atom and other atom will be surrounding atom. One criteria, or one more thing is, the atom which is least electronegative will be a central atom and the more electronegative atom will be the surrounding atom. So here in case of BF3, we knew that fluorine is highly electronegative. That means boron is least electronegative. The other thing, fluorine is 3 in number and boron is 1 in number. That is least in number. So in both the cases, boron will be central atom and fluorine will be surrounding atom. Now let's have total number of electrons. Total valence electrons will be 3 for boron plus 7 into 3 for fluorine, because 3 atoms of fluorine are here. So it will be 3 plus 21, it will be 24 valence electrons we need to show. Let's start. We will write boron in center, then 3 fluorine in its surrounding. The first thing we will do. Second thing, we will give 3 electrons to the boron, which is itself belonging to boron. Then we will take 3 atoms from fluorine to make a bond. This 3 atoms belong to fluorine. Now what will happen now? This fluorine and boron will make a covalent bond. Now how many atoms are left after using this 6 electron? So we will 24 minus 6, it will be 18, and these 18 electrons are called as lone pair electrons. Lone pair. This 18 electrons should be used to complete the octet. First we will complete the octet of surrounding atom, then the leftover electrons will be used to complete the octet of the central atom. So for fluorine we will use 1, 2, 3, 4, 5, 6. Now 1, 2, 3, 4, 5, 6. Every time we will give lone pair, means a pair of electron, like this. So let's count. On this fluorine we have 1, 2, 3, 4, 5, 6, 8 electrons on first fluorine, 8 electrons on second fluorine and 8 electrons on third fluorine. It means all the 3 fluorines has completed their octet, and in this way 18 electrons are used. Now there is no more electron left to complete the octet of boron, which is having 6 electrons here. Now in this case, what we will do? We don't have any extra electrons. So in some cases, In some experiments, what they say, the lone pair should be used either as a lone pair or we can use it as a double bond or triple bond. So in some cases, some scientists use that to make a double bond. But in that case, boron and fluorine having some charges. And after some experiments, it is found that the charged BF3 is not correct, and this structure is experimentally correct. So that's why this is called a Lewis dot structure of BF3, in which boron is having 6 electron in place of octet. So we can say BF3 is an exception by its incomplete octet, and that is true. So every time whenever you draw the BF3 Lewis dot structure, you will leave the boron with 6 electrons and need not to force it to have 8 electrons. Thank you. Till then, bye bye. Keep studying. Thank you.